Hello! So today we're going to be diving into the May 2024 paper 1 higher paper for Edexcel. And if you're looking for any specific questions, the links will be below to them. But otherwise, our game plan is essentially to dive in, see what we can do. And I really do suggest that you pause the video before diving into each specific question. But yeah, without further ado, I'm going to just start tackling this paper and we'll see how we get on with it. So question 1 here, it's looking like we've got an arithmetic sequence. So to tackle this, we want to figure out the difference between each term. Here we're seeing increments of 4, as you can see, going up by 4. Yes, each time. That looks quite nice. Excellent. This means that we want to create an equation that has 4n in it. Okay, this means that every time we plug in a value into n, we're going to increment our sequence by that amount. But you'll notice if I start by plugging in our first term, so our first term would be when we substitute 1, we'd be at 4. I don't want to be at 4, I want to be at 1. So I'm going to have to take away 3. And it's always a very, very good idea to take these and just double check that everything works with them. Maybe you can format it like it's a little machine. So if I plug in 1, 4 times 1 take away 3 gives me 1. If I plug in 2, I go 4 times 2, 8 take away 3 gives out 5. Right? So that's all right. We've started off there quite nicely. 4n minus 3. Perfect. So our next one, work out 3 and 4/5, take away 1 and 2/3. Cool. So non-calculator paper here, we're doing a subtraction. So it's very important that we ensure that our denominators are the same. So for our fraction over here, what we do is we multiply the number on the outside by the denominator, and then we can add the numerator. So in this case, we'd end up with 19 over 5, and on the right we're going to end up with 3 times 1 is 3 plus 2 is 5 over 3. Perfect, but we're not in a position right now where we can subtract these because our denominator is different. Pictorially, think of this like different sliced pizza slices. You can't take them away from each other if they're different slices, so it's important that we ensure that these are the same. We do this by finding a common multiple, and in the case of 5 and 3, the first common multiple is 15. So we'll make both the denominators 15. And then all we need to do is think about, how many times do I need to multiply our denominator to get to that number? So on the left, I'm going to multiply top and bottom by 3. So 19 times 3, maybe you want to do this off to one side quickly, but 9 times 3 is going to give us 27. And clearly the 10 times 3 is going to give us 30. Therefore we're left with 57. Cool. And then on the right, we're going to end up doing this one times by 5, so we end up with 25. As such, we end up with, what's this going to be, 32 over 15. And it doesn't specify here that they want it as a mixed number, so we can leave it as that. Yeah, excellent. Cool. And for part B here, we've got Kevin. Kevin's decided to do some maths, good for him. And we see some workings. Let's see if we can figure out what he's done wrong. This is looking okay. 7 over 3 there is perfect. 5 over 8's looking okay over here. Okay, let's see where this is going. 35 over 24. That seems suspiciously okay. So I'm hoping it's going to be a problem down here. Oh yeah, lo and behold, right, he is gone from this step to this step incorrectly. Notice that if you took 24 away from 35, you'd in fact be left with 11 over 24. So what mistake did he make? He couldn't take away 24 from 35 correctly. Okay. Moving on to question 3 now. So we have a floor plan. It looks like a compound shape, but nicely it looks like it's going to be made out of 2 rectangles. And in this scenario, Petra here is going to be covering the floor with paint. Fantastic. Okay, so we've got 3 tins of paint, and there's 2.5 litres in each tin of paint. She thinks that 1 litre will cover 10 squared meters of floor. Okay. So maybe even before even considering what the area is of our shape, let's actually figure out how much floor she can actually cover. So the floor she can cover is going to be 3 paints times 2.5 times by 10. So we've got 3 times by 2.5 times by 10. Cool. This looks like it's going to be 7.5 times by 10, which is going to be 75 meters squared. Cool. So we're in a position now where we can very quickly decide yes or no if she's got enough paint to cover the floor. Cool. Let's go back up here and analyze the size of our shape here. So we can see here that this part is going to be 8 by 6, and then this side is going to be 4 by 5. Notice I figured that out because this length was 10. We've got 6 down the bottom here. So quick bit of maths, right? 8 times 6, hopefully we can see that there's going to be 48, and then over here we're going to see that this is 20. Summing these together, we're left with 68. So clearly the floor area is equal to 68 meters squared, which is less than our 75 meters squared of paint. Which is great, because that means that she can cover the floor. Perfect. Here we are. So actually 1 litre of paint would cover 11 meters squared of the floor. Okay, awesome. Does this affect your answer in part A? No. No. All that's going to do is mean that she can cover a little bit more area, but of course we found that the area of the floor that we wanted was still less than this. So we are all okay. You must give a reason for your answer. So no, 11 meters squared per litre only increases the amount she could cover, but we already have enough. Cool. Something like that would be perfect. Amazing. Okay, moving on. Question 4, Venn diagram. So Venn diagrams, usually leaning into probability a little bit here. And to begin with, we want to write down all the numbers that are in the set of P dash. Now, P dash means in words, not in P, right? So if we were to quickly outline all of the ones that were in P, let me just grab them here. So this is everything that's in P. Doesn't matter that there's that line there is from Q. Okay, so all the numbers that are not in P are everything outside of the circle that is P. So we've got 10, 11, 13, 14, 16, and 17. A number is chosen from the universal set. Find the probability that this number is in the set P or Q. Fantastic. So P or Q, unlike P and Q, which would just be 18, P or Q means that it could be anywhere within the 2 rings. Okay, boosh, there we are. So there we go. That looks like it's going to be, find the probability. Haha, I almost nearly caught myself out there. We have got 9 numbers in total, and 5 of them are inside our ring. A little tip for many of these probability questions is that you can essentially think of the division as the words out of. Cool, so a little tip there. Awesome. Moving on. Sophie drives a distance of 513 kilometers on a motorway in France. She pays 0.81 euros for every 10 kilometers she drives. Work out an estimate for the total amount that Sophie pays. Cool, so an estimation question. You're usually allowed quite a lot of leeway with how much you move numbers here. So in this case, I would round our value down here to 500 kilometers, and I would up the value to €1, €1 per 10 kilometers. And then here, right, we can now very quickly see that we're going to cover 50 times 10 kilometers, which means that it's going to be about €50. And then we're asked underneath, is your answer to part A an under or an overestimate? Well, it certainly feels like we're rounding a lot more from 0.81 to get to €1 per 10 kilometers than we're rounding down from 513 to 500 kilometers. So I'd say it's certainly going to be an overestimate. In other words, in reality, it's a lot cheaper, almost a fifth cheaper, per 10 kilometers. So actually, in reality, we could expect that this value of 50 euros would actually be closer to maybe 41 or 42. Cool. Excellent. Okay. Question 6. We're given a straight line graph. Usually quite nice. Our formula here that I would definitely recommend is going to be y equals mx plus c, where y and x are just the coordinates that are being passed in, and m is our gradient and the c is our y-intercept. So quite quickly we can see that c is going to be 3, and then our gradient, a good way of remembering what gradient is going to be is for every one across I go, how much do I go up or down? Here we can quite quickly see that for every one across I go up 1.5. Maybe this isn't so clear, and you could actually take a step back and go, oh yeah, if I go across 2, I end up going up 3. So every one is going to be 3 over 2. Excellent. So here we've got y equals 3 over 2x plus 3. M is a different straight line with equation y equals 5x. Write down the equation of a line parallel to M. For a line to be parallel, it must have the same gradient. In other words, it must have the same steepness or angle that it's going off at, but you're just shifting it up and down on your axes. So you can pick any value here, y equals 5x, plus some value c where c is not equal to 0. So, for example, I just picked y equals 5x plus 4. Okay, nice one. Okay, moving on to question 7. Kazim has some small jars, some medium jars, and some large jars. He has a total of 400. 3/8 of the 400 jars are empty. All right, feels like we should probably start off by just figuring that out. So if we took 1/8 of 400, we'd end up with 50. Therefore, 3/8 is equal to 150, leaving us with, what's that going to be? 250 that are in use. Anyways, we keep on reading onwards. For the empty jars, the number of small jars to the ratio of medium jars is 3 to 4, and the medium jars to large jars is 1 to 2. Okay, it looks like we're wanting to actually see the ratios here. So a lovely way of doing this is actually to just go small to medium to large, populate a sort of graph underneath. So small to medium we're told is 3 to 4, and then beneath this we're told medium to large is in fact 1 to 2. And what we're looking for is a way of unifying our ratios so we've got all 3 parts in one thing rather than spread out over 2 separate equations. To do this, we want to ensure that values are consistent. Think of it like your denominators in a fraction. And it's certainly looking like we can make the medium values in this second equation 4. So if we go 3 to 4, well, to get this 1 to 4, we've got to multiply by 4. So the same for this 2, which will become 8. Cool. So work out the percentage of Kazim jars that are empty and small. So now we're going to have to use this to our advantage to figure out, well, actually, how many of these empty jars are small ones. The way that we do this is actually we'd count the total for the ratio. 8 plus 4 gives 12, plus 3 is 15. So that means that there's 15 parts, so to speak, in total. If we then were to look at this value down here, so the total number of empty jars is 150, and this is split into 15 parts. Quick division here will tell you that this is going to mean that each part is a value of 10, and as such, we've got 3 parts that are small, where a part has the value 10, and as such, 3 times 10 is 30. We actually want the percentage here, not just a value. So actually, we'd be looking at 30 over 400, and if we wanted to turn this into a percentage, we typically want to divide our denominator here by 10, not by 10, divided by 4, leaving us with something over 100. Thinking about what 30 over 4 is, you'd realise quite quickly, I hope, that this is 7.5. In other words, this is 7.5%. Wonderful. Question 8. Len has 8 parcels. The mean weight of the 8 parcels is 2.5 kilos. The mean weight of 3 parcels is 2 kilos. Work out the mean of the other remaining 5. Fantastic. So means are an interesting thing, right? We add the total weights of each, and then we divide it by the number that we included, or the number that we counted, and we end up with some remaining value. So in our case, right, let's take the second part as an example, right? We have 3 of these parcels that have a mean weight of 2, but it doesn't necessarily mean that each of them was 2, but the sum of their weights was 6, right? It must have summed to 6, because if you were to divide it by the number of parcels, 3, you get 2 kilos. So in essence, you can end up modelling the larger group of parcels as though that these 3 were in fact each 2. Okay, so we're going to say that 2 plus 2 plus 2, right, plus all of these mystery weights, let's just call them x for now, all divided by 8 is going to be equal to 2.5. Now this is interesting, because all of a sudden actually this just becomes a rearranging question. Multiply by the 8 and we're left, and simplify this over here, and we're left with 6 plus 5x is equal to 20. Hopefully starting to spot that this is quite a nice rearranging now. 5x equals 14, and x is equal to 14 over 5. And that will give us the mean value of each. Now, that feels a little bit strange. I can understand that. You're not finding the exact value of each, because that's impossible currently. But you can find the mean value, and the mean value assumes that each of them is actually the same, or each of the 5 that remain. And that's exactly what we've done. 14 over 5. Cool. All right. In a sale, the normal price of a coat is reduced by R%. Given that the sale price is equal to 0.7 times the normal price, find the value of R. Okay, so let's have a look. Find the value of R. Reduced by, unless this is trivial, I think it's 30%. 30% reduction. In other words, you start with your normal price, say £100, and you end up at your sale price, which would be, in this case, £70. Thinking about what that would be as a reduction, it's just the opposite way around, right? You're reducing the normal price by 30% to get to 70. Question 10. The fateful simultaneous equation, right? There's actually a whole host of different ways of solving this. So if I go about solving it in a way that's slightly different to your method, I wouldn't worry. Ultimately, these all rely on your solution. So let's dive into this. So looking at this on the surface, there isn't actually a particularly nice way of cancelling values or setting them equal to each other. That's one of the classic methods. Oh, I've got 2x in both the top and the bottom one, right? And then you can set them equal to each other and they cancel out. In our case, it's not so clear that that's an option. One could argue that you could multiply the top equation by 2 and the bottom by 5, making them both 10x and setting them equal to each other that way. Potentially that could lead to us having more integers. And yes, I think that might actually be the way that we tackle this question. So the top equation, we're going to make it become 10x minus 4y equals 46. Notice I've just doubled everything. The second equation, we can then multiply everything by 5, once again giving us 10x, taking away 15y, and slightly harder question here, 18 times 5, times it by 10, divide by 2, equals 90. Okay, cool. Part 1. Now, we don't want these equations both being 10x minus 4y or minus 15y. We actually just want them both equal to 10x. So if we take both equations and rearrange them slightly, we're left with 10x equals 46 plus 4y. And down here, we're left with 10x equals 90 plus 15y. Now comes the clever bit. Well, clearly if 10x is equal to 10x, they're the same thing inherently. Well, these bits must be equal to each other. So 46 plus 4y must be equal to 90 plus 15y. Excellent. Now, we've managed to cancel out our x's. We're left with no x's remaining. We've just got an equation in terms of y, and that's fantastic because it means that we can solve for y. So usually I would advise you want to keep your y's positive. Numbers, they don't really matter so much, but you always want to keep your bit of algebra positive. So let's try and move this 4y across to the right, and we're left with 90 plus 11y, right? We're taking it away. And then we end up with 11y. 46 minus 90 is going to give us minus 44. And as such, to get y by itself, we end up with minus 44 over 11 equals, let's just figure this out quickly, minus 4, which is equal to y. Fantastic. So now we've got on our equation for y. We can take this right the way back to the start and see if we can figure out our value of x. We could use either of these equations, but I suggest that we use the second one. Why not? You could check it with the other. But if we had 2x minus 3 times minus 4, it's going to equal 18. Excellent. This leaves us with 2x minus 3 times minus 4 gives positive 12 equals 18. Therefore, 2x equals minus 6. No, absolutely wrong there. Positive 6. And x, in fact, equals 3. Perfect. Now, it's usually worth passing these into the other equation just to double check everything's going okay. So 5 times by 3 minus 2 times minus 4 equals 23. Let's just double check that this is okay. So we are left with 15 plus 8, which does in fact equal 23. And this actually just lets us validate the fact that these two values must in fact be correct. Cool. So just to sum up, our x value was 3 and our y value was minus 4. Okay. On to question 11 now. So triangle A is translated by a vector, 6 minus 4, to give triangle B. Triangle B is then rotated 90 degrees clockwise about the point 1, 2 to give triangle C. Describe fully the single transformation that maps A onto triangle C. Okay. So, let's figure out where our translation takes us. 6 minus 4 is a vector, which means that it's moving by 6 in our x direction, moving 4 negatively in our y direction. Okay. So usually the nicest way to do this is to just pick a point on our triangle. I'm going to take this one over here, but you can take any of the points, and we're just going to move 1, 2, 3, 4, 5, 6, and then we're moving 4 downwards. 1, 2, 3, and 4. Excellent. Then all you need to do is just copy out what the shape was originally. So here it is. There it is. And this is B. Excellent. Triangle B is then rotated 90 degrees around the point 1, 2. Here it is. So 1 across, 2 up. That's over here. So that's pretty rough. And we're rotating it clockwise, right? Remember clockwise, if you ever get lost, just look for the clock in the exam hall and you'll be like, oh yeah, that's the way it's going. So I've always thought about doing this by trying to figure out a particular point on your triangle or whatever shape you're dealing with. And you just want to think about what would happen if you moved that line by 90 degrees. So for us, I'd consider this here. Let me actually just increase the size of the pen here. So 1, 2, 3 across and 2 down. After a 90 degrees rotation, think about it was like holding on to like an axle or a pivot at this point. You'd in fact be going 3 down and 2 across this way, right? And this is attached to this point. So if we were to draw our new shape, it would be like this. All right, that's a bit of a sketch, but there we are. And that would be C. Excellent. So our question now is to figure out what transformation would move A to C immediately. Now, this doesn't seem like it's quite the easiest thing, but clearly there's some rotation involved, right, to get from A to C. And hopefully you can see that actually it's going to be rotating clockwise as well. But to get ourselves there immediately, we've got to think about what point would actually trigger this to happen. Now, I'd say, you get tracing paper in an exam. That would be something that you'd use to your advantage. You put your compass or whatever in a point, and then you can sketch out your shape and just move it around that point, and eventually it'll line up with where you want to go. But for us, I'd suggest that our point would be right here. Initially, you start by moving one to the right and one up. If you rotated this round by 90 degrees, you end up going one down and one across, and you end up at the same point as you would there. Excellent. So to quickly summarize what our transformation would be, it would be a rotation clockwise 90 degrees at point -4, 1. Okay. Ooh, so we've got a whole host of different graphs here. Now this is tough, and potentially something that a lot of people won't have seen in too much detail, because a lot of these graphs, these ones particularly, this one, this one, this one, a lot of these graphs are more A-level style content, but it's good to be aware of them, and with a little bit of luck we'll be okay here. So let's start with part I. I is defined by its highest power. In this case it's x squared. X squared in this case is positive, and this helps us figure out what type of graph it is. The positive x squared graph is H. So this is a positive x squared graph. Note it's kind of like smiley face sort of characteristic. The next equation we've got is defined by a cubic equation, and in this case it's actually a negative cubic equation. This is in fact letter F. And then last but not least, we've got y equals -5 over x. This would be J. This is a -1 over x graph here. Now, I think it's an excellent question, and something that I get asked a lot is how would I cope with one of these questions if I've not ever seen these graphs before? A classic quick thing to check is actually just to plug in a few x values. There's nothing ever stopping you from doing that. So you may have seen before the tables that look like this, and you can plug in a few x values. I would suggest just do -2, maybe 0, add +2, and this will just give you an idea of what to look out for at each of these values. So for example, for x minus x cubed, here we'd be looking at -8, and over here we'd be looking at +8, and 0 would actually give 0. Say if you did the same thing here, -2, 0, 2, you might think, oh, these graphs look awfully similar, but note that the 0 value here leaves us with a divide by 0 error, meaning that you get an asymptote at this point. But yes, otherwise, that would be how I'd approach it. Excellent. Okay. Seems to be going well. The table gives information about the amount of time that each of 150 people were in a shop. Okay. Got to draw a histogram. And wonderfully, we've been left with no axes, and actually we've not even been given titles on our axes. So we've actually got to be pretty careful here. We're going to end up with time down here. And remember that frequency is actually defined by the area within our blocks. So let's start by figuring out our time. It starts at 0, ends at 60. So with any luck, they've given us 6 boxes. 1, 2, 3, 4, 5, 6. Oh, fantastic. So this is going to be 10, 20, 30, 40, 50, and 60, And apologies if my graphs are a little bit scrappy, I'll use a slightly larger pen. So we're told that between 0 and 10 we have a frequency of 20, so our area must be 20. Sometimes with these it's quite useful to try and figure out which one the tallest bar is going to be, and then you can work accordingly from there. This takes a bit of skill, but you can usually pretty quickly pick it out. You want a small horizontal width and something that like quite a large frequency, which implies that you must have quite a tall vertical height. So maybe we could even create another column and call it height. So for this one, we've got a width of 10 and a frequency of 20. That means the height must be 2. Here we've got a width of 20 and a frequency of 70, which means the height must be 3.5. Here we've got a width of 5 and a frequency of 22. That's going to actually be giving us 4 4/5, or not 4/5, 2/5, which would be 4.4. Here we've got 15 and 30, which would once again be 2, and here we've actually just got 0.8. Okay, so actually the highest up we want to go is a little bit less than 5. 1, 2, 3, 4, 5. Oh, perfect, right? So by doing that little exercise, we've actually been able to perfectly see why our table that we've been given in the question is this size. Bit of luck, and we can actually just go around now and fill in all of these values. So there you go, there's 1, 3.5. What's our gap here? Going all the way up to 30. The next one is going just to 35, but it has a height of 4.4. So let's be as close as we can there. There it is. The next one going from 35 to 50 has a height of 2. There it is. And the last one has only a height of 0.8, going to 60. Fantastic. Some would argue as well that it's certainly worth our time to actually just label on all of the frequencies. So 20, 70, 22, 30, and 8. Fantastic. Work out an estimate for the fraction of these 150 people who are in the shop for between 20 and 40 minutes. Okay, so that means that we're wanting to look at the gap between this point this way and this point here. Now you'll notice that we're not given actually the full area of 2 of these parts of our histogram. The 70 has been split in 2, and the 30 we've actually only got a third of. Remember, it was 35 to 50 minutes. Now, the thing that we assume here, which can sometimes lead to a follow-up question, is that all of these values have been equally distributed within the time that we're looking at. For example, the 30 people that were in the group of 35 to 50, we assume that they were spread out equally between the 35 to 50 minutes. But in reality, all 30 of them could have been in the 49th minute, for example. But using this fact, we can then assume that in the 35 to 50 section, which had a frequency of 30, that 10 people were here. How do I work that out? 30 divided by 3, because our time is 5 minutes out of the total of 15. The same logic here, 35. And as such, we are left with 35 plus 22 plus 10, 45, 67. Out of 150. Yeah, asking for a probability there. You can't simplify that, I don't think. Nice. Excellent. On to question 14 now. We want to expand and simplify this triple bracket equation. That's going to end us up with a cubic. So this is going to be interesting. With these, I certainly recommend the nicest way to do it is we just want to start by looking at 2 brackets, and then we'll run through again with our final bracket. So for us, there's no particular order. I'm just going to say, let's get the harder bits done over and done with. 2x plus 3. 3x times 2x is going to give us 6x squared. 3x plus 3 is going to give us 9x. Minus 1 times 2x gives us minus 2x. Minus 1 plus 3 gives minus 3. Let's just tidy this up quickly. And we are left with 2x squared plus 7x minus 3. Fantastic. So Now we are left with this thing, 6x squared plus 7x minus 3. And we want to multiply it by the remaining x minus 5. Now there's a few different ways of doing this, but I'd suggest we start by multiplying the x squared by x. We're left with 6x cubed. And now we're going to think about the two different ways we could get an x squared. Multiplied by the minus 5 times by the 6x squared gives us minus 30x squared. And the x multiplied by the 7x gives us 7x squared. We now want to consider what will give us just an x value, and that's going to be minus 5 times the 7x, which is going to give us minus 35x, and x times minus 3, which is going to give us minus 3x. And last but not least, the constant at the end is going to be minus 3 times by minus 5, giving us positive 15. Tidying all of this up, and the perk of doing it in this technique means that you just end up with these little bits of simplification in the middle, and you're left with 6x cubed minus 23x squared minus 38x plus 15. Cool. And yes, I would leave it at that for 3 marks. Cool. Question 15. We have a sector of a circle, a pizza slice, and it has a radius of 6. The length of the arc of AB is 5 pi centimeters, and it says work out in terms of pi the area of the sector. Okay, so we're told that this arc length over here is 5 pi. An arc is a section of the circumference, right? Around here. Now, we don't know what value of theta we have here. We don't know what our angle was. Now, using a bit of maths trickery, we should be able to figure this out. Most people, in fact everybody doing this exam, should definitely know what the circumference formula is off the top of their head, right? 2 pi r or pi d. But a lot of people often forget what the formula is for arc length. But it's quite intuitive, really. If you wanted pi d, or the whole circumference, you'd want the whole 360 out of 360 degrees. But if you want an arc length, you just want a specific section of the degrees out of the full 360 rotation. That thus giving you just a section of the circumference. So our arc length formula is theta, or sometimes people use x, over 360. Think of that as the amount of angles I want out of the total rotation, just multiplied by your 2 pi r or pi d. We'll use 2 pi r in this case because we've got radii in our question. Excellent. So for us, we can now do a bit of maths, a bit of rearranging to figure out what our angle would have been. So theta over 360 times by 2 pi r, our radius is 6, 6 is equal to 5 pi. Okay, so a couple of quick things to notice here. Pi's can initially cancel because we've got 1 on both sides, so let's just do that. And then another little bit of math trickery is remember that these multiplications can act in effect as though they're on the numerator of this fraction. And multiplying fractions by other fractions, you can chop and change how the fraction effectively looks. You do have to be a little bit careful there. But essentially, you can end up with theta multiplied by 12 over 360 equals 5. Now, through that little bit of rearranging there, note that 2 times 6 has given us 12. We're in an excellent position now to figure out what value we've got here, which is in fact 30. So we end up with theta 12 over 360 is going to give us 1 over 30 equals 5. So theta's still multiplying by this thing. And that means that our theta ends up being, well, 30 multiplied by 5, which is 150 degrees. Okay. So we're only part way through this question, but now we have theta. Now we're interested in our sector area. And it uses a wonderfully similar bit of logic. We don't want the whole area, we want some angle of that area, we want some fraction of it. And now we wonderfully know what our theta is. We can say that, well, I want 150 degrees out of 360 degrees of the full area of the circle. Pi r squared. Wonderful. So our radius was 6, so we're left with 150 over 360 times by 6 squared pi. A little bit of simplification and rearranging here. We want our answer in its simplest form. 150 over 360 becomes 15 over 36, which will become, what's that going to be? Divide by 3, 5 over 12. 5 over 12 times by 36 pi. Oh, we're going to need a little bit more space here. I'll go up again. We'll end up with 180 over 12 pi. And at this point, thankfully, both of these nicely divide by 6, giving us 30 over 2 pi. Oh, and look, we can go one step further, 15 pi. Very nice. I suspect there would have been a nicer way to do that, actually, in retrospect. 6 squared gives you the 36 over 360. They would have cancelled. Yes, that would have been just that little bit easier. And then you would have been able to divide by 10. The 150 would have popped up much quicker there. Or the 15, sorry. Question 16. There are only n orange sweets and 1 white sweet in a bag. Okay. Sarah takes a random sweet from the bag and eats the sweet. She then takes another sweet from the bag and then eats that sweet. Okay. This looks like a conditional probability question where we've got n orange sweets and 1 white sweet in the bag. Now, the first thing I'd take out of this is that the only implies that there are only orange and white sweets. Wonderful. And we can take away from this a total. The total amount of sweets, therefore, must be n plus 1. Now we just need to figure out what the probability is that she eats 2 orange sweets. Now we could make a full tree diagram here, but I don't see any point really. We want to find out the probability of her choosing orange the first time, and then the probability of her choosing orange a second time. Now, that means that for each fraction, each probability, we want to consider how many are orange compared to the total. In the first case, we're going to have n over n plus 1. And in the second case, well, we've removed 1 orange sweet and we've removed 1 from the total. So we're left with n minus 1 over n. As we know, to work out the probability of this thing actually occurring, we actually want to multiply down the branches. For example, if you had a coin toss with a probability of being a half landing on heads, and you wanted to figure out the chance that it was heads twice in a row, well, you want half of that half, giving you a quarter. So, in our case, we want to multiply these two things, n over n plus 1, multiplied by n minus 1 over n. Important aspect to remember here is that when it's on your numerator or denominator, it's kind of nice to think of it as though it's got brackets. Multiplying fractions, things just squidge themselves together, and we're left with n minus 1 over n plus 1. And you'll realise that regardless of what value of n you've got, you'll have this value of n on the outside multiplying both the numerator and the denominator, which means that they can cancel, leaving you with n minus 1 over n plus 1. Question 17. 2 third questions here. These look like they should hopefully be okay. So rationalise the denominator at 1 over root 7. Rationalising the denominator, well, rationalising means that you have some irrational value. In our case, root 7. An irrational number is any number that can't be described with integer values in a fraction. Okay, so even though some rational numbers are infinitely long, take 1 over 3, most square roots are irrational. You can't describe them using a fraction. Pi is another example of an irrational. What we're trying to do is get ourselves a rational number in this denominator. And the way that we do that is we multiply top and bottom by our denominator here. Note that we end up with a numerator that's now irrational, but doesn't matter. And on the bottom, we do root 7 times root 7, which is in fact just 7. Yay. And then on to part 2 here. It says, fully simplify. Root 80 minus root 5. Now, root 5 can't be simplified at all because 5 is in fact a prime number. You can't factor 2 values out of it. So actually, we're looking for some multiple that goes into 80 5 times. This will probably become clear in a moment. So what thing goes into 85 times? Well, 16 times 5. Haha. 16 also happens to be a square number, which is perfect. So you'll notice we've got this scenario now. A very interesting property is that you can separate out 16 multiplied by root 5. Root 16 times root multiplied by root 5. Take away the root 5 here. And of course, root 16 gives 4. So we're left with 4 root 5, take away root 5. Taking away surds is something that people often get caught out by. If you ever get stuck, just remember that you could say let root 5 equal x, and then you're just left with 4x minus x, which is 3x. In other words, 3 root 5. Question 18. So here we've got 2 recurring decimals. We actually want to add them 2 together. And we want to show that it can be written in the form m over 66, where m is an integer. Oh, okay. Seems fairly heavy. So the trick is for recurring decimals to turn them into fractions. We want to find the bit after the decimal place. And we want to find 2 versions of that where it's the same. Take them away, and the recurring bit that goes on infinitely forever ends up cancelling out. So for example, if we took our 0.15 reoccurring, we'll say that x is equal to 0.15 with those bits reoccurring. If I take 10x, this is therefore going to be 1.51 reoccurring. But notice they don't cancel out. They're not the same. We couldn't cancel them. If we try to take away the 1.5 reoccurring from the 5.1 reoccurring, chaos would ensue. But if we go up to 100x, well, we're left with 15.15 with the 1.5 reoccurring. And notice now, if we were to take away x from this 100x, those 1.5, 1.5, 1.5, they'd all cancel perfectly. So that's exactly what we're going to do. 100x, take away x. It's exactly the same as 15.15. Take away 0.15, which is equal to 15. 99x, and as such, x is equal to 15 over 99. We could simplify this now. Our target wants us to get over 66. You'll notice that you can divide top and bottom by 3, and then multiply by 2, leaving you with an equivalent fraction of 10 over 66, multiplying top and bottom both by 2/3. Potentially a little bit hard to spot there. Secondly, we're going to run through the whole entire scenario again with 0.227 reoccurring, and we'll see what we get. So actually, just to be super clear, let's call this y. Y is equal to 0.227 reoccurring. 10y is going to be equal to 2.27 reoccurring. It doesn't quite line up, okay? This 7 starts cancelling with the alternating 2's. So we need to go a little bit further with this one than we did even last time. 22.7.27. You could argue that at this point things are starting to line up, but still I don't think it's the nicest. We're in fact going to go one further to 227.27. And now notice this version here is going to cancel very nicely with this one. No troubles, no questions asked. The 2 7s are recurring immediately after the decimal point. And as such, we have 1000y. Take away our 10y is going to give us 227.27. Take away 2.27. We're left with 990y is equal to, careful here, 225. In other words, y is equal to 225 over 990. Gosh, and now we need to find out what this is going to be over 66. Okay, So we figured this one out over here, 10 over 66. But now we need to start tackling this one. I would suggest that probably our nicest entry point is dividing by 5. Seems the clearest that would go into both top and bottom here. So let's start by doing that. How many times does 5 go into 225? Well, this is going to be 45. Why? Well, 40 times 5 goes 200, then 5 times 5 is 25. Similar logic can be applied to 990. It is, in fact, 200 times that it goes into 1,000. So actually we're looking at 198 times on our denominator. Okay. This seems to have moved us a little bit closer to our target, but ultimately we're still not quite there. It's hard to immediately see what our next division would be, especially with the numerator being odd and the denominator being even. In this case, I'd suggest that the first thing that I spotted was actually divide by 9. So I'm just going to carry on pairing through this. So you end up with 5, and then on your denominator, you'd end up, in our case, with 22. We're in a good position now, because actually all we need to do is then multiply back up to get to 66. I suppose there was actually a divide by 3 here that would have gotten you there. But regardless, 15 over 66. And as such, we're left with our two fractions, 10 over 66 plus 15 over 66, giving you 25 over 66. And there's your integer m. Tough for 3 marks. Okay. So in this question, we've got two similar isosceles triangles. Interestingly though, ABC has been rotated relative to DAB. I'd almost be inclined to actually redraw a lot of these sides. I think that would make our life a lot easier. So actually I think that's exactly what I'm going to do. We've got triangle ABC here, and we've got larger triangle DAB down here. Now we're told that AB is equivalent to AC. Okay, that's because it's isosceles, and AD is equal to BD. That's because the larger triangle is isosceles. We're then told that the ratio of BC to CD is 4 to 21. BC to CD. Okay, yes, that would be some point over here. Fantastic. And the ratio of those two lengths would be 4 to 21. Find the ratio AB to AD. Okay. So, let's see where we can start here. If BC has this part here, this would be a length of, say, 4. Well, therefore, this length up here must be 21. But notice that BC, right, is also the section here, meaning that the full length down here is in fact 25. We know that this also must be the side over here, and that seems to help us, because, well, how can we then figure out the scale of our smaller triangle? Well, we know it must be some multiple of the bigger triangle. Now we're looking for AB relative to AD. We're trying to figure out the scale factor of this side to the bigger side. So what we can say is that actually this length here, x, is exactly the same as this length here, x. Interesting. So we can say that 4 multiplied by our scale factor, let's call it SF, is going to be equal to x. We can also say that x multiplied by our scale factor must be equal to 25. As such, we get left by quite an interesting equation where we've got our value that is shared and our scale factor. If we take this second equation and make sure that x is equal to 25 divided by our scale factor, well, we can now set our first equation equal to our second one. As such, we're left with 4 times by our scale factor is equal to 25 divided by our scale factor. They're simultaneous equations in disguise. Now, I suppose what happens here is that you're left with your scale factor squared is equal to 25 over 4. In other words, your scale factor itself is going to be equal to 5 over 4, technically a plus minus, sorry, not 5 over 4, it would be 5 over 2, and technically, yes, you'd have a plus minus here, but we aren't inverting the size of this scape. So, there you go, the scale factor is 5 over 2, but our question is asking, what's our value of AB relative to the length of AD? Well, we're told that the scale factor from the smaller triangle to the larger triangle is now 5 over 2. So we can say that x multiplied by 5 over 2 would have been equal to 25. Inverting this tells us that x must be equal to 10. And as such, we're left with our ratio AB is 10 to AD's 25. Tough question. Question 20. Given that x plus y equals 8, and those two equations, work out the value of n. Okay. So, to figure out this one, I think it's interesting to actually consider what would trigger an x plus y in the numerators. For this to happen, you'd have to end up multiplying 2x by 2y. And this would cause 2x plus y. For example, maybe this isn't particularly clear, but if you had 2 to the power of 3 multiplied by 2 to the power of 4, well, you'd hope that it was 2 to the power of 7. Excellent. So we can, using this, we can now go, that's quite interesting. We can change what we've got here. We've got 2 to the n divided by root 3 of root 2 multiplied by our root 2 all to the 5 is equal to 2 to the 8. And now it's just our job to figure out what n is going to be equal to. Now I just start applying a little bit of logic here and going, well, 2 to the power of a over b is exactly the same as the bth root of 2 to the a. Okay, let's try and get everything into that form. So we have 2 to the n, and we've now got this over 2 to the power of 1/3. And over here, we've got root 2 actually to the power, all to the power of 5. So this actually becomes, not a square root there, it would be 2 to the half, all outside of the power of the 5. Next step is actually realizing that anything on a denominator is the same as a negative power. So we can say that we've got 2 to the n multiplied by 2 to the minus 1/3 multiplied by power inside a bracket multiplied power on an outside bracket gives you 2 to the 5 over 2. Excellent. We want this all to be equal to 2 to the 8. You'll remember that when you're multiplying your bases, your indices just add. So now we've essentially created an equation that says n minus 1/3 plus 5 over 2 is equal to 8. The nicest way to now approach this is to give everything the same denominator, and essentially we just want to move everything to the other side. So n is equal to 8 minus 5 over 2 plus 1/3. I would say that the nicest way to do this is to get everything over 6. So n is equal to 48 over 6. Take away, what's this going to become? Multiplied by 3, 15 over 6, plus times 2, 2 over 6. And as such, you are left with n equals 48 minus 13 gives 35 over 6. Okay, now on to question 21. A solid cuboid has a volume of 300 centimeters cubed, and the cuboid has a total surface area of 370. And the length of the cuboid is 20 centimeters. I'd definitely suggest that this is one of those questions where you want that diagram. So I'd say that this is our length, 20, going this way. And then we're going to have some height and, what are we using? Height and width. Okay, cool. So we're told that the volume is going to be 300 centimeters cubed. So remember that that's just multiplying everything. So 20hw is equal to 300. And secondly, the total surface area is going to be 370. Now, that's a little bit more complex. But with the cuboid, you've got three different types of face, each of which appears twice. So take, for example, this face here. It also appears over here, which means that if we find it once, we can just double the value. So this face, for example, would be 20h. We've got it twice, so it's going to be 40h. So that's 40h. The same thing happens for the bottom of the top. 20w once, twice is going to be 40w. And then the square at the end is going to be hw times 2. So it's going to be plus 2hw is equal to 370. Okay, fantastic. From here, I think our best option is we've got a similar pair of units here and here. If we can scale up this whole bottom equation by a factor of 10, we can substitute in this 300. Okay, so as such, we're left with 400h plus 400w plus 20hw multiplied by 10, but this is going to be equal to 300, is equal to 3,700, sorry. Okay, excellent. So now we're left in a great position where we're actually left with 400, which has been factored outside h plus w, is equal to 3,400. Okay, great. So we can now say that h plus w is equal to 8.5. Cool. 3,400 divided by 400 is 8.5. Isn't necessarily the nicest answer, I don't think. So potentially we can find a nicer way to equate this, and nevertheless we haven't actually found the value of h that we're looking for just yet. So let's rearrange. H is equal to 8.5, take w, and you could actually go a little bit further and say that maybe 2h is equal to 19 minus 2w. Okay, so we're not quite there yet. We actually want to think of a way of making this work for us. And to do that, we actually want to just substitute right the way back into our equation up here. We know that 20hw is equal to 300. And, well, we now know the value of 2h's. Okay, that's cool. So we divide everything by 10. We end up with 2hw is equal to 30. Everything's been divided by 10. We now know the value that 2h is 19 minus 2w. So we can say that 19 minus 2w multiplied by w is equal to 30. In other words, this is looking suspiciously like a quadratic equation. We actually end up with minus 2w squared plus 19w equals 30. Great. I'd move everything to the right-hand side. So you end up with 2w squared minus 19w minus 30. From here, it's a case of trying to figure out what our quadratic is actually going to end up being. A couple of different methods for this. I think I'm looking at this going, oh, there probably is a nice solution, but it's not coming to me straight away. Something doubled, multiplied by each other, maybe a 10 and a 3. Not quite, because neither of those doubled is going to give 19. Maybe a 6 and a 5. 6 gives 12 minus the 5, not quite. 5 doubled minus the 6 doesn't give 19. 15 and 2. 15 and 2, okay, this is looking promising. Okay, so it's going to be minus 15 minus 2. Yeah, minus 15 minus 2. And we want the 2 being doubled. So we've got to have 2w here and a single w here. Excellent. And we know that this is equal to 0, and as such, your two remaining values are therefore going to be when 2w minus 15 equals 0, in other words, w is equal to 7.5, or when w minus 2 is equal to 0, so w is equal to 2. Now remember the condition that we set ourselves earlier, h plus w is equal to 8.5, and we wanted our height to be, the width of the cuboid is greater than the height. Oh, perfect. So that means that by definition, our width must be 7.5 to ensure that it is greater than the height. 7.5 centimeters. Excellent. Question 22. Sketch the graph of y equals sine x. Okay. There isn't really much you can do here without a calculator. If you've forgotten this, you've forgotten this. But if you do remember it, it starts at 0, 0. At 90, we reach a height of 1. At 180, we return down to 0. At 270, at 270, we'd return to -1 and then back up here to 0. Solve the equation 2 times sine x equals -1. I think the nicest way to realize how to solve this is actually you've got sine x is equal to -1/2. So you're wondering when your line of sine x is now equal to the line of -1/2. The line of -1/2 is clearly just going to cross through here. We're going to hit some value down here, and we're going to hit some other value over here. But that doesn't give us too much help. That is, unless you've remembered your exact trig functions. You'll remember that sine of 30, in fact, gives us a value of 1/2. And using the same logic, we can realize that this value here must be 210. It's moved 30 degrees away from the point where it crosses 0. The same thing must be true of here. It moves backwards by 30 degrees. So there are your two answers. That's quite difficult for a GCSE paper. And last but not least, we have question 23. And in this question, we have got a circle with center 0, 0. L is a straight line. The circle is C and the line is L, intersect at the point P and Q. The coordinates appear 5, 10, and the x-coordinate of Q is -2. Interesting. Okay. L has a positive gradient. It's going upwards and crosses the y-axis at the point 0, K. So on the surface, it feels like this wouldn't have just the one value of K. You've got some circle, right? And at the point, say 5, you're at a height of 10. So you're up here. This is point P. But I think the thing that might catch people out is that your x over here, you know that point Q is a distance of -2 away. But this value up here, notice because it's closer to the peak of your circle, it must be above point P. So actually, we're interested in this value down here. This is going to be our Q. So let's start by seeing if we can figure out our radius. This is going to come in useful. So we know that it's 5 across, and we know that it's going to be 10 up. Therefore, we can define our circle equation as x squared plus y squared equals the radius squared that we find here. So this will end up being 5 squared plus 10 squared, which is 125. And our radius of our circle is, in fact, root 125. Okay. So it's our objective in this question to find 0k. And we want to find the value of k. We now have the equation of our circle, and we have a lot of information about this line, including its coordinates at point P. We're yet to find the two coordinates at Q. I feel like it's probably our best interest to find this other set of coordinates at Q, and then from there we can find the remaining value that is going to be our intercept at K. We know this point must in fact lie on the circle as well, so plugging in our x-coordinate -2 squared and adding y squared equals 125. Interesting. -2 squared becomes 4, plus y squared equals 125. Fascinating. Look at this, panning out very nicely. Y squared is going to be equal to 121. Y is equal to plus or minus 11. And we've figured out that we actually just want the negative value. The positive value would be up here, and therefore the line would have a negative gradient. So there we go. We figured out our coordinates of Q. It is in fact minus 2 and negative 11. Now, using the 2 points, we can now figure out the equation of our line. I think the fastest way to do this would be to find our change in y over our change in x. So our change in y, well, we move 21, and this one moves 7, therefore it is 3. And now we can say some y coordinate, y equals mx plus c. We now want to figure out what c is. Let's just pick our coordinates up here. 10 is equal to 3 times by 5 plus c. And that means that 10 equals 15 plus c. Therefore, c is equal to minus 5. And that, coincidentally, happens to be our value of k. Our line L intersects the y-axis at 0k. There it is. And that's the end of the paper. Cool, nicely done. I hope that was useful, and I hope the revision is going well. Do let me know if you've got any questions with any of the particular solutions on this paper. But otherwise, I will see you soon. Cheerio.